Kia ora everybody and welcome. My name is Kevan Cote and I am a data scientist on the EcoIndex program, part of the Bioheritage National Science Challenges. And today we're going to be talking about wetlands and how we are using remote sensing data, satellites and AI to detect them across Aotearoa. First, just a little bit about the EcoIndex program. What we are is a group providing guidance towards restoring, protecting, and connecting our native ecosystems. We have set a goal of restoring native ecosystems back to 15% of their original extent by the year 2121, so 100-year goal. And we're providing information to allow people who want to support that endeavor to come on board. The reason that we're doing this primarily, and I'm sure many of you know, is that our current situation is a lot of our native ecosystems are falling below that 15% target. And so a little bit of a data here. There were originally around 3 million hectares of wetland across Aotearoa, and now there's currently about 300,000 hectares. So, about 10% of the original coverage. So that's why our focus is on this, this lower area, and specifically today we're talking about wetlands. Now, satellite imagery has come a long way, especially in the last few years. We have many satellites available to us with different types of imagery, higher resolution imagery, multispectral imagery, etc. I've listed a few of the key attributes here that we're specifically using for wetland detection. But reading through that, you can start to see that having satellite coverage of the entirety of New Zealand, not having to rely on smaller airplanes to hopefully cover it, it's quite a powerful tool to have for us. So that's why we're using a lot of this satellite imagery for our work. And what I want to describe a little bit is multispectral imagery, and I'll go through a few different data types here, but many people sort of have heard multispectral imagery, but they might not really understand what that means. So I'm sort of doing try to show it visually here for you. We have a partnership with Planet Imagery. They're providing a lot of the satellite imagery for us, so that's been incredibly helpful. What I've done here is highlighted an area just outside of sort of where we are, actually, where I'm located, just outside of Kirikiriroa, the Kopuatai wetland. And what you'll notice is when I overlay a multispectral image, so this is a near infrared band, what it essentially is doing is it's showing us how much greenness of the vegetation is being reflected. So it's not quite chlorophyll content, but similarly related. And the darker red areas are showing a higher greenness content, with the blue areas being less greenness in them. Now if I sort of zoom in here, it gives you a bit of a better shot. So what you can see in the wetland is definitely a sort of a distinctive pattern. We have these blue wetter areas. Obviously that's the water sort of reflecting back, these wetter zones, and then these darker red, these vegetated areas. The key thing to notice here, though, is it's a very different signature from the paddocks and the areas around this. And I'm going to say this a couple times, but there are these spectral signatures that we're looking for in the data. And this is really what we have found key to being able to detect these sort of unique areas, if you will. Another partnership we have is with the Rongawai program, part of the Geospatial Research Institute, based out of University of Canterbury. And what they have done is they have attached a sensor to the bottom of an Air New Zealand plane, which is specifically aimed at measuring soil moisture content. Quite unique, which is amazing. There's actually satellites that do this as well, but as you can imagine, a plane is much closer to the Earth, therefore able to get a higher resolution image, as well as actually see a little bit further into the Earth's surface than a satellite could. Another main advantage is what you can see on the right-hand side of the screen there is the flight path of an Air New Zealand, this specific Air New Zealand plane. Very good coverage of the North Island, which is fantastic for us, but also very frequent. It's flying a commercial route, so we can get images of the country 3 to 4 times a day, which you just don't get with a satellite. Satellites are approximately once a month for a full coverage image. Can be a bit more frequent, of course, depending on the satellite. But yeah, we're really excited to have partnered with them and be using their data. Another important aspect that I want to relay is what we're calling the sort of the ecosystem extent modeling that we're doing. As I mentioned, Planet Imagery is a partner with us, and they provide an entire image of Aotearoa, New Zealand, one every month. So every month we get a new updated coverage of the country, which allows us to do things like start to look at how ecosystems are changing. And what I've shown here is a bit of indigenous forest, bit of native forest just outside of the Waikato. And what you can imagine is as this extent starts to grow, we can actually map this. And especially month to month, if not year to year, we can really start to see a grow or a decline. Hopefully not a decline. Hopefully our ecosystems are growing, and we can start to put that into the model and start to see how these models are changing and really add that data. So now, what is putting all this data together? We're using artificial intelligence. We're using machine learning techniques. Many of you, I don't know how much experience, but it's not quite just a brain on a computer. It's simplified down to a point where what we're doing with AI is we're taking all of these data types that we have. We're taking that multispectral image layer. We're taking that soil moisture layer. We're taking that extent changing and as many layers really as we want, and we're stacking them together. We're creating sort of a data sandwich, if you will, or a data cube. And what that does is the model goes through that data cube and it looks for patterns, looks for these spectral signatures throughout each of those layers. And knowing where wetlands currently are, we can start to put that into the model. And the model will then look for similar signatures throughout different parts of the country as well. And in essence, that's how the machine learning will work. That's how the neural networks chew through. And then we create this model that looks for wetlands. As you can probably think, it's a very powerful way of taking a smaller amount of known data and then really expanding it across the country, because we're letting the computer do the work. It doesn't have to be people actually visiting each of these locations by person. Now, I'm going to show you a little bit of very early on data that we've run. This is part of a indigenous forest model. This is just a little clump of bush sort of in the southern Waikato over by Parongia. And many of you might be familiar with the LCDB database. It's a very common database run in 2018 that went across the entire country and pointed out a lot of different types of land cover. So what I've pulled out here is the indigenous forest land cover layer and just overlaid it on top of an image from very recent, from 2013. Then we ran our model, our machine learning neural network on top of this. And we noticed what the model was doing was that it was actually picking up on the differences. What it sort of says is that between 2018 and 2023, there's going to be some changes in the forest. That's 5 years of growth. So it's really neat to see that it can start picking up on some of these growth areas that you can see have connected those three separated patches of forest together. There's obviously still room to grow. This is not a finished model by any means. These are very early results, so take that with a grain of salt as well. But that is what we're hoping to do, and then run these with, instead of indigenous forest models, run them with wetlands data feeding into them. So what are our next steps? Well, we need more data. The Rongawai program that I talked about earlier on, the soil moisture, is still in its early stages, so we're just working with them to get that data feeding into our models, into our possession as well. Obviously, we need continual expert feedback, because we need to know that what we are looking at is correct. I'm not an ecologist by trade by any means. I'm a data scientist, so I rely heavily on the ecologists that are on our team who are absolute experts in the field, as well as we have partners with regional councils sort of for their local data. Our initial model that we're going to be running is going to be looking at wetlands of all types. So we're clumping everything together initially. What we're going to do is then once we find those wetland clumps, we'll be running through again to differentiate the different types of wetlands. So that's sort of the next step on our agenda as well, is to start pulling those into their separate categories so we can get a better representation of what the wetlands are. And then finally, it's to run our models across Aotearoa. We're focusing initially on the Waikato as well as the Wellington region, because that's sort of where our expertise is. That's where we're based in the Waikato. And we have partnerships with the Wellington Regional Council as well for some of that data. So that's where we are currently. Ngā mihi nui, and I welcome any questions.